So welcome to lecture 21 of NCS 507, a course on mathematical, statistical and scientific software. So this lecture follows lecture 19 on web interfaces. So I will briefly uh, indicate again what we remember from CGI scripting. This lecture is more geared towards user administration. So one should never store passwords. One generates a hash, one applies a hash function to encrypt a password. There is the SQL database language, and I will give an example on how one can set up a database, how one can manage a database from within Python. And towards the end, I will indicate how one can authenticate via email. So in one way, if your organization has email and you would want to restrict your web service to only the members of that organization, then you can authenticate via email. That would actually save you to do your own password administration. So anybody who has a particular email from that organization can then use your web service. Okay, so Python comes in with batteries included. So we can work with Python code that prints HTML forms used to collect input from the user. The form is printed by Python, and also the information is processed with Python functions. So Python is the P in the LAMP, the LAMP, and the M stands for the database. So the L is for Linux, the A is for Apache, although it's platform independent. And for what we can do here, Python also comes actually with a web server, so you can run everything on localhost. So the other module we need is the SMTP library, where we can define the user administration. So the registration process that goes in a two-step email registration, and then one can also provide an automatic password recovery control. And as always, we test things offline first on localhost. Okay, so every user account should be protected by a password. A password should actually never be stored in plain form, so they should be encrypted. The encryption is typically a trapdoor function. It's quite easy to generate the encrypted form, but computationally extremely hard to compute the inverse. So if somebody gets the encrypted versions of the passwords, then it still will not help. So the keys should also actually be, on the other hand, large enough, so that there is a very low chance that you will get the same encryption for different passwords. So the authentication is then whenever the user is prompted for the password, the authentication then happens by doing the encryption in the script, and then one compares the encrypted password that the script does with the stored encryption. Here is how we can generate an encryption. Of course, Python has an answer to that. There is a module, and here is how we can use it. There is the hash lib. We take a string and it gets encoded. The hexadecimal, so what comes back from the encoding is an object, and what we store is the hexadecimal representation. Okay, let's practice this. So we have seen that we can store information in cookies. So we will go next to a database, but let's store this first in a cookie. So that is useful if you essentially do not want to store the password information on your server, but the cookies are stored at the client side. So if the user generates a password, it actually will never leave the computer, but it's only when it's the user wants to log in again that then the check will be made if the same password is used. Okay, so in a way this is a repeat or a call of lecture 19. So this is entered here to make the lecture more self-contained. So we have two scripts. One script, cookie login, prints the form, and the form is then processed by the second script, the cookie user pass. And what will here be done is that the user pass will simply print the encrypted password. In an actual application, this user pass would, when granted, would then continue with the application. To check this, I will not demonstrate this here, but in the live class I will do that. So one can run the web service with the MyServer script that we've seen in lecture 19, and rerun the cookie login twice. So the second time when the user connects, the password does not need to be prompted. Okay, here is the script. So the scripts that are being executed by the web service, so this will be localhost at port 8000, they are running with the interpreter. The path to the interpreter is the first line. So we are using the CGI toolbox, and we enable the error messaging. So we are going to get a cookie, and we're going to send a cookie. So this script gets executed on the browser, on the server side. So the server is running the script. A cookie is made and is being sent to the browser. So this is what the first print statement does. So this is the CLP that gets printed, and then the printing of the form, which is HTML code, to the browser. So what the user will see happens then next. Okay, the function getCookie will make a cookie. Either it will retrieve it if there is no login and no password, then the fields login and password will be initialized. They will be created. Okay, so now comes the form. So we will print the form to ask a name. So the values, if this is the first time, so then the vlog and the vpass will actually be empty. So, and we will test on that. So we will process the cookie. So here you see if the login name is empty, then the login name will be prompted. Else, the login name will also be printed. So here you see that we retrieve from the vlog. We use the vlog, and in the text element we print the value of that string, which is in this case not empty. And here the usernames are restricted to 20 characters initially. Then we do the same for the password. So for the password, essentially if there is already a password, then we simply we do actually not do anything. So the form is then end. If the password is empty, then we will print a text element to prompt for the password. So this function either prints one or two text elements, and the very last print statement prints a submit element. So that will be the button to submit. And that is printed no matter what. So that's not behind the condition. So this is then the second script that is called when the user hits the submit button. So when the cookie login, then the form is then processed by the second script. So here is the beginning of the second script. So the second script will get the cookie. And again, this gets executed by the server, and the cookie gets printed to the browser. Then we process the form, so processing the name. The process name returns Boolean, and if it's not an error, then it will process the passing. Otherwise, it doesn't do anything. Okay, so let's retrieve. So what does the get cookie do here? It gets the data from the form into the login. So here again it checks whether there is this cookie already. If there is a login here, then it will copy the login account from the form into the cookie, into the simple cookie, and the same happens with the password. If the password is already there, then it will copy. And essentially it copies the encrypted password. So the form is what the user typed in, but what is stored, and this is the third last line here, is the encrypted password. And that gets stored in the cookie. Okay, so there are several guards here. So the conditions are that the fields are available in the form. There are no exception handlers with this script. So if the user doesn't type anything in, just hits enter, then an error message should appear. So it's an error message that then is generated by the CGI toolbox as it is enabled. All right, processing the form. Well, here is the error message. So if the form didn't contain an error message, so I kind of misspoke here, there will be an error message printed. Please enter your name, and the return value will be set to true. Otherwise, if everything went fine, if the name is entered, then a welcoming message is displayed. Okay, then processing the password, it prints the encrypted form that is now stored in the um, cookie. Of course, in realistic applications, we would compare with the password stored on file. And on file here means that it is stored in a database. So that's now the next part. Okay, so how do we manage? So I should say about the previous part. The scripts cookie login and cookie pass W are posted. The my server script is posted with lecture 19, so please try this out. Should probably have demonstrated this, but this treatment is, I admit, rather dry here. Okay, and this is a rather crowded slide. So MySQL is an open source database. I checked the my database, the MySQL is still that it's not my database, but the MySQL is still alive and very well in use. So open source. Is typically free, but that doesn't mean that it has no value. Here you see that Oracle acquired Sun and Sun acquired MySQL for very large numbers. So there are alternatives to MySQL. So if you use MySQL, you also need the MySQL DB, so the Python interface, to be able to use the database from within Python. An alternative that will save you that interface is PyMySQL. So that needs to be installed separately. The Python then comes with a built-in database. So there are three possibilities here. Why am I continuing with MySQL? Well, MySQL is another example of client server. It also creates a more realistic um, setup. So there is a client and there is a server. On the server computer, you need to start up the daemon. So it's very similar to Apache. So Apache needs to be started if you want to do some web servering. The same with the database. If you want to serve a database, then you need to make sure that it is up and running. So this can be done at boot time. So there are start scripts that automatically start certain services. If not, you will need to start and eventually then also shut it down. So this is here done. I think I executed this on a MacBook, but it's very similar with the as you do, but it's very similar on Linux, on Unix systems. Okay, first things first. So let's start to create um, a user account. So typically, the MySQL runs at root. You need to give the users on your computer access to the database. So that will be the user that runs the Python script on your server. So typically, one can run everything as root, but that is not recommended at all. So um, one restricts the root at the starting and the stopping of the service. Um, okay, so the adding of the users also actually happens to run the administrator privileges, so that also is typically done as root. Here the administration of the database will be done by the user, and the user will have all privileges to do this. So there is a database, and there might be several databases, and every database consists of several tables. So a table you can loosely identify with a file. One database is a collection of files that are dealing with one particular application. Okay, then there is the creation of the database. So there is the user administration, then there is the creation of the database. So we create the database with the MySQL admin. We can create it and we can delete it. So that's the drop. It's good whenever you create something that you can undo it. Sometimes you don't come up at the first time with a very good name. So here the DB name is kind of a silly name. Okay, so MySQL itself is a large application. Some people, well, I think some people, so there is the SQL language, there is a structured query language. It now seems that we are going into one very particular application, and what does this have to do with scientific software? But essentially, we are learning another language, and which is quite general. So, and you do not really need to to learn much. So there is this structured query language in which you formulate queries to retrieve records, insert records, delete records, and update records. So the command syntax is always very the same. You select, so you first use a database. So whenever you start, so now we are in the the MySQL client. So we have the MySQL server up and running. The MySQL is the client that will make the requests to the server. So first what you do is you indicate which database you want to use. Then you look which tables do you want, what tables are available. If there is nothing there, you create a table giving the fields. If there is a table, you can explain, you can use the explain to see what the fields mean. So the fields have data types. Okay, so then a query, in a very strict sense, it would seem that you could only look up information, but a query is extremely general, so you can add information, delete information, or update information. And you can select, the select can be done with be subject to additional criteria. So you can ask for a sorted list of items that meet certain criteria. All right, let's create a very generic one. So for example, we'll create a book where every book will have a unique identification number. There will be a title, and then suppose that we are managing a library, we will indicate whether the book is available or not. So we have regular integers, we have small integers, and we have strings. So you see we can have strings of limited size, so 80 characters here. So when we do the create, then it's very good to do the explain to see whether everything was as intended. So now we can select, so we, after inserting a value, so suppose that we have a scientific software book and it's not available, that's our first book, so we can select everything from the table book. And we can also select specific titles. That's the use of the where clause. Okay, so now how do you do this with a database, and why would you do this? So Python is very good. So the commands so far were interactive. So this is very good to get a feeling of how to work with SQL. Um, Now, you do not want to do a manual entry of all the data. So either you will let will let this happen via an automated web service where users are filling in entries in the database, or often you want to do an automated data entry. So you want to fill up your database with computed information. So this could be also extremely good to. So this is a course on scientific software after all. So this could be a very good tool to systematically um, collect your output of your runs. So if you want to especially say that this is software that changes in time and you want to see the evolution of which problems have been solved and what was the output, what was the running time, what date was everything solved, you can make this very well structured, managed with a database. Okay, so there is the PyMySQL now. So the PyMySQL is another interface to a database. So, and there's not much that you need to remember. So there is the PyMySQL, which is the alternative to the MySQL DB. So that's the alternative interface. So I'm probably here only explaining the PyMySQL. Um, the point is that you do not need to know another language. So the commands that are executed are actually the SQL commands that you would type in. So we run a query. That's point 4. So the importing, the connection, and the cursor. So you can see the connection to the making the client up. Giving the connection is kind of another name for the client, for the MySQL, and then the cursor is what you will use to pass the commands, the SQL commands, to the to the client. So whenever a MySQL command is executed, it returns the number of rows in the result. Then you can get the row count separately, but you can then get the results row by row, or you can get everything. So a little bit similar to reading a text file line per line, or reading a text for all the lines. Here is an example. So this is the PyMySQL database to the database that we have created, so our scientific software book. We import MySQL. So here, obviously, again, the MySQL needs to be up and running. So we do the steps. We import the Python module. We connect to the database. We make a cursor, and then we can pass SQL commands that we practiced before. We can pass them through the execute of the cursor object. And here there's only one line, so you see what returns is the tuple. So there's only one field that we select. Okay, so tuples, by the way, is also synonymous with the row if you look into the database library literature. Tuple is equivalent to what is a row. A tuple is also a Python object. Okay, we're almost there. Do not think that I will spend the full 50 minutes on this lecture. So I have, for the live version in class, I have some demonstrations prepared, so that will make it a little bit longer. The scripts are posted. Installing MySQL is recommended if you plan on doing something with it later. You can also investigate SQLite, the built-in database with Python. Okay, if you set up your web administration, you want to send messages to your users of your web service. You do not want to have this done via your own personal email account, so you most likely have a dedicated email account for this. Python has the SMTP library, and you can connect through the email server. So we are again doing client server computing. So Gmail has a server, and you can connect to the server via a Python script. So you need to set up again a client. So what we do here in these three commands, we create an SMTP object. We provide the name and the port number. So the port number is 587. So that is used by the service. If everything is fine, then it is ready to start the communication. Now, if you have a Gmail account, you cannot use your Gmail password directly because there is typically the two-factor authentication. So, and you don't want for every user that connects, you don't want to confirm via your cell phone that indeed it is a valid thing. No, you can have that on the computer that will run the Python scripts. You can generate one specific app password. You need to do this via your Gmail account, and there are instructions available for that. Okay, so how can we authenticate email? So in a way, this could already be useful. That somebody has to have a valid email address. And Gmail provides free email addresses. So it might be that you do not want that people sign up with these fake emails. So it might very well be very good practice that you want that only people with a valid Gmail address sign up to your service. So that's already one layer that you can check that somebody who signs up is really so then you trust Google that they have these identification management. Okay, so there are the instructions that were done on the previous slide interactively. Now they are in a script, so this is the start of a script. Now we will start the client to communicate with the Gmail server. So the script continues, and here is where the interactive part comes. So the user is expected to add a valid account, and then here the Gmail is added to this. So the get pass here will have to be the device password. So I said that you could do this from users, but probably this is I misspoke here. So this is you at the server side. So this is a good check when you want to set up your web service from your computer. So here I practiced this on a Windows laptop, that this script will work. So that this, if you type in here, so if you do the get pass, so the get pass is different from the input, so the password will not be displayed as you type it in. Okay, so the result will be printed. So if no exceptions happening, then success will be true, and you will have been authenticated. You will have access to the email. And what can you do with this? Well, you can send email messages to this. So when a user accesses your web service, you will access your uh, the sign up process. So you will start the sign up process. So you will authenticate with the email address that is used for the communication with the user, and that's now the user of your web service. You are of course also user of the Gmail service. Um, and here you will do the authentication. So this is at the service side of your web service, where the account is what you use to communicate with the users of your web service. Okay, so now comes the sending of the email. So the signing up process is a two-stage process typically. So you will reply. So when the user wants to sign up, you will send an email to the user. So this is also a check whether the user has provided you with a valid email address. So first we authenticate at the server side. Again, we authenticate to Gmail. We get then a server and a user where we can send an email. So we will send the email to the user, and if the sending of the email was fine, then the return is just an empty dictionary. So then it was accepted for delivery. Here is how the sending of the email works. Now the message is accepted for delivery. It can still happen that the spam folder needs to be checked. Some automated, automatically sent emails end up into the spam folder. How does one send an email? Well, one can essentially also send a plain string, but it's good if one has a subject. So if one uses this multi-purpose internet mail extensions, also available in Python, then one can give a subject line there. One can also check what the message will look like. So here is the short version of the message. Okay, one can make this very interactive. So here is the sending of the email, where the user is prompted for the destination email address, the subject, and then the body of the message. And when the script is executed, then an email is sent to the destination address with the given subject and the body. So here you see the result, which is the sending of the email to that particular user via the send mail of the server. If everything went fine, we will receive an empty dictionary, which is returned. Okay, one last slide. So I hope I have indicated the basics of a registration activation process. So typically the registration sends the email with a unique token in there, which also which takes the a form of an encrypted password. So in a way, with every request that is being made, there is already one entry that is generated in the database with a temporary password that is unique and that is emailed to the user. So the email contains a URL. So before the slash CGI bin is the URL is what appears in the HTTP in the browser window. And when the user clicks on it, it will essentially use the code that is sent and it will activate the login. So, and that is then, so there is a registration script and then there is the activation script. In essence, you can practice this also on the local host, where everything is local host and where you use your own email address to practice this. So the activation essentially checks whether the unique password that was generated actually matches what is stored. If so, then actually one has access and the user is ready to use your service. Okay, so I hope that this was useful. So here's some proper some suggestions for exercises. So we did this with a cookie, the password information. You can use a file, a plain file, to store the password at the server side now. So the second exercise asks you to set up a table for your customers of your web servers, and then you can write the registration scripts and the activation scripts. Okay, so as I expressed earlier, I hope that this was an interesting lecture. So it seems a bit odd in scientific software to have this here, but note that software isn't generally not so much installed anymore. Many users prefer that the software runs on a computer which is properly configured, and also even that the data is kept at the server side. So that could be another database that one typically maintains. One has the database with the user information, but one then also has the database with the data that is stored by the users. Okay, thank you for watching this video. So this lecture follows lecture 19. There might still be a follow-up lecture on Jupyter Hub. So there is the Jupyter Notebook, but then there is the hub that essentially provides entire Jupyter notebooks in the web service. Very similar like you would use CoCalc, for example.